Welcome everybody. My name's Doug Young. I work for the University of Guelph in Ridgetown campus. I'm what they call a college research professor. But one of the things that I do is I teach soil science. And so today what we're going to do is we're going to look at some soils. We're going to talk about some of the soil properties that are important for the Envirothon. And we're going to learn a bunch of things about soils that you may not have known prior to this video. Today we're going to take a look at a soil pit, what we call a soil pit. It's just a hole in the ground, but it's a special hole because it allows us to see all of the features of a soil. And some of the features of the soil we're going to look at in this particular video, we're going to look at horizons or different layers in the soil, and we'll also talk a little bit about how this soil got here and how we get what we get where we get it. And so we'll talk a little bit about that. So this I've got my fancy stick today, so that's my pointer. But this is called a soil profile. Okay, so from the surface down to, in this case we have water in the bottom of the hole because the water table's high, it's springtime. So down to where the water is, we call that a soil profile. And that profile allows us to see different layers. So we have a layer here, we have another layer that starts here and then goes down deeper. So in this case, we have three different layers called horizons. Okay, so the top layer we call topsoil. It's called, the official name is called the A horizon. Soil scientists are real creative people, so they call them A, B, and C. But anyway, so we have an A horizon at the top. We call it topsoil, typically. We have a B horizon in the middle. That's called subsoil normally. And then below we have a C horizon starting about here and going down, and that C horizon we call parent material. Okay, so we have topsoil, subsoil, and parent material corresponding to A, B, and C horizons. What makes the A horizon special, the topsoil special, is that it's much darker in color than the other horizons, typically. And the reason why it's darker than the other horizons is because it has lots of organic matter in it. Organic matter, when it decomposes, has a very dark color. So around, in this area here, we have a bunch of trees. So when the needles fall, when the branches fall, and when the undergrowth dies every fall, organic matter gets added to the soil and organisms can mix it into the soil. So that's why we have this layer. Another reason why this layer is so uniform, and that's because this area here used to be a farm field. And when tillage was done, tillage is always done at a uniform depth. So you get a very uniform depth of topsoil typically. And normally the depth of topsoil would vary quite a bit. But in this case we have a fairly uniform depth of topsoil because of the tillage that was done here probably 30, 40, 50 years ago or more. Okay, so topsoil has lots of organic matter. Organic matter tends to have lots of nutrients. Organic matter also helps with the soil structure, and we'll talk. And there's another video that we'll talk about that. So we'll leave that for the other video. Underneath in the B horizon, you'll notice the B horizon has a different color. It's very easy to tell the difference between the A horizon and the B horizon because of the color change. In this case, the color is on a reddish. Is reddish. That red color is from iron oxide. It's from the rusting of iron that's in the soil over time. So oxygen gets into the soil and it oxidizes the iron and produces this yellowish reddish color. That tells us something really important about this soil. That tells us that this soil is well drained. In other words, it dries out fairly quickly. So in the spring, the water will drain through the soil fairly quickly, and when water drains out of the soil, it gets replaced with air. And that air oxidizes the iron in the soil. So we want well-drained soils for things like agriculture, because that allows farmers to get on the fields earlier in the spring and allows for drier conditions at harvest. So we get a longer growing season because of that. The drainage is going to affect the natural plants that grow in an area. Okay, so well-drained areas will have different species growing than poorly drained areas. Okay, so the wetter areas. So that's that color is important in the B horizon. The C horizon, the parent material, in this case, it's a little bit different than most because this is all sand. The A horizon and the B horizon are sand. We get on the B horizon and we start getting into some clay. Okay, clay is the smallest size particles. It's harder to drain, and it just has different properties than the sandier A and the B horizon here. So in a soil profile, we have typically 3 horizons, A, B, and C. We can have more, we can have fewer, but normally we'll have usually 3. And that will help us determine how that soil was formed, as well as it helps us place that soil into a what we call a soil order. So just like when we classify things, soils, it's just like classifying plants and organisms. We have a system for that, and in soils, we use the profile, the horizons, the order of the horizons, and the type of horizons that we have. So this A horizon is enriched in organic matter. B horizon has lots of iron in it. And the C horizon is essentially what was there when the glaciers left 10 to 15,000 years ago. Okay, so that's a quick little story about the soil profile.